All right. Thank you so much for joining. Thanks for coming, Patrick. I didn't think you'd make it. Well, thank you so much. Um,
I didn't think you were going to make it. I was waiting for you, man.
I was on a call with Anand, with Rahul, I think 30 minutes before the call, and Zoom started acting up, so it got very tricky. I had to restart my computer and all of that stuff, so it took longer than usual. Okay, so I actually want to show something I call CQLAlchemy, which was inspired by SQLAlchemy. I think that using Cassandra is a bit too tedious for like ordinary people who just want to put stuff in a database and read it and query it. Uh, Cassandra is full of really, really smart people who are very esoteric, you know, and I think building the right tooling and the right frameworks can help a lot more ordinary people actually try this thing out and build much more apps on this tech. So I'm hoping that Rahul and Co will give me one more chance to do part two of this because I think we're going to run out of time very quickly. But I'm going to just try and pack this talk with as much stuff as possible. So this is part one. It's going to be part two at the end. Maybe on another day we can do part two. Right. So what we're trying to do is just to kind of like build um, something that looks and works like SQLAlchemy on Cassandra. That's robust, easy to use, and also very, very tunable. You want it to be able to make it very easy for new people to start building stuff on Cassandra. You want to use as much Python as possible. You don't want to have people kind of like switch context in their minds when they're trying to build stuff. You want to have a lot of powerful batteries out of the box. And then you want people who are really experienced to be able to do a lot more with it. So want it to be a force multiplier for people who are very experienced. And then, of course, building on Cassandra is not just about putting stuff in the database and reading it and querying it. You also want to have migrations. You want to have revisions and auditing and all the stuff that you need to build a complete web app. I think if we do this right and we can be really patient because SQLAlchemy is about 20 years old right now, I think we can build something that's really remarkable for the long term. So, so what we're doing with this is we're taking all the great work that's happened on the Cassandra driver in Python, and we're building a much friendlier layer on top of it that just allows you to do stuff. Um, but I think the most important thing that we're introducing to Cassandra, especially for Python developers, is actually this unit of work concept, which I think is very important if you're going to build large apps that really work well. So I'm going to go very fast. If I'm going too fast, you can just tell me to slow down and I'll slow down. Okay, so right. So I think the easiest way to start using this thing is to create a class called an expander. And expander is really an entity that you can just add keys and values to arbitrarily, and it just expands and it just works, right? So you can create an expander class and and just put stuff into it, right? So you create an author and just pass some attributes to it, and and that just saves it in a database, and you can read that and just make sure it's actually saved. So notice how you're not creating any tables, you're not syncing anything, you're not you're not connecting to any databases. It just takes care of all that stuff for you, right? So this stuff actually has some videos attached to it. I'm going to try to go through the videos very quickly because I didn't want to run code during the presentation, right? So this is a really simple expando. You create the expander. You can actually just put stuff in it, call author to create, and that saves creates a person, and that's in the database already. And then you can run this, and what that does is just executes the whole thing. You can read from the database, and it just prints stuff out. So it works exactly like you expect. Um, So this creates a table for you, handles the connection, uh, takes data you're putting it, yeah, you're putting into it, serializes it, deserializes it, and I just present it to you very easily. Right. So this is the easiest and the lowest hanging fruit if you're actually building stuff. So I know you guys like really technical definitions for stuff in the community. So what you have here is really a dictionary-like entity which you can add, remove, query, arbitrary key value pairs. You can create wide rows with this very easily. And when you're starting to build an app, you're not really sure of the schema, you're not really sure of how you want it to look, you just want to get going, you can use Expando to do that. And it just works, right? Um, there's also this thing called an array. And what it is really like an expando, but it's like a one-dimensional, like durable array. That's backed by Cassandra. You can just put stuff into it. So this is used exactly like an expando. You define a class, inherit an array, and you can just put stuff in it, right? Um, and so this also works if you're just trying to store stuff. But I must tell you, it's actually bounded, right? So you can't put 1 million entries here, right? You're gonna have to cap it to I think 65K, which is like the limit under the hood. But it works just fine. So there's an array, and that works just like you expect. So these are like the entry level classes. If you just want to just put stuff into Cassandra, you're not really worried about schema. You're not really worried about how it's structured and all of that stuff. You can just store stuff. You can read it and you can query it. So you have an expander, you have an array, and I think the last thing that we have around here is sorted sets. Um, all this code is available online. I'm going to share it and you can try it on your computer and play with it, right? So the last is actually just a sorted set where you can just put stuff and save it and read it, and that just works, right? So that works as you expect. I don't want to waste so much time going through this video. So basically, an array is a durable, bounded, one-dimensional like array-like entity for Cassandra. It has LIFO and FIFO access. And of course, sorted set is actually bounded and it's idempotent, right? But at some point, you'd want to have some kind of schema. You'd want to be able to say, oh, I want my model to be like this. I want it to have this kinds of columns. I want to put these types of values into it, and so on and so forth. This is what people expect when they see an ORM. So CQLAlchemy actually has um, that stuff. So to actually get a model like this, you'd inherit from model instead, and you just import these properties from SQLAlchemy and you just add them to your model. And it works just like you expect. So if you've used SQLAlchemy or you've used SQL Engine or Django models, it works exactly the same way. Um, and so you just create a model and you can create an instance of it, and that saves it to your database. And you can modify it and you can save it. So what this does really is that the model tries to figure out the quickest and the most performant way to kind of like save your instance to Cassandra. So if you create a model and you modify just one or two columns on it, it saves just that. And it tries to be really, really, really um, it tries to be smart about it. So let's look at how that works in real life. Um, so so we define an author. In this case, create a bunch of properties for the author, and then you can instantiate like you can create a new row in the database by calling the author create method. And then, of course, you can save that and you can query it with author.read, and that works exactly like you expect. Um, so we're trying very much to make the API very, very familiar. So if you've used SQLAlchemy, if you've used Django models, if you've used Tortoise ORM, you'd feel right at home actually using CQLAlchemy. So basically, a model is like the basic way to put stuff into CQLAlchemy. So it maps your objects, it tracks changes to it, and it applies those changes in the most performant way. I'm going to go into what performance means later on in the talk. But I don't want to get ahead of myself. So the model is actually mapped to the class name is mapped to a table, and an instance of that class is mapped to a row, and the attributes in that class are mapped to columns. Now, you'd see these things in a model. You see string and UUID and email and so on and so forth. Those things are really properties. It tells you how you want your model to actually be saved, how you want it to be validated. And you see things like saying the UUID is the primary key. You make that by saying primary equals to true. We know that that's a primary key. This UUID is actually a type 7 UUID, so it's actually really fast and easy to use because it's time sorted. Um, and when you say you want, when you mark a property as required, you're telling SQLAlchemy to say, you know what, you need to make sure every author has a name before you actually store it. When you say you want it to be indexed, you're asking SQLAlchemy to go behind the scenes and create an index that works for this author. And I think it's pretty obvious what it should actually do. Um, so we have like a long list of properties. I think there are over 30 of them that do different things. You've got strings, you've got email, you've got password, you've got currency, you've got all the stuff that you need to build an app on a day-to-day basis. Um, um, and it's pretty easy to just write your own, right? But we can't go into that in this talk. Um, so basically, everything you need to build an app, most of it has already been built and already exists in SQLAlchemy. You just import it, add it to your model, and you're good to go. Now, there's a property that's very interesting here that I want to talk about a bit. We call it reference. Now, I know that Cassandra folks are very big on having your data denormalized. Um, you don't want to have complex relationships in your data model and so on and so forth. But if you've built any reasonably large app, you realize that you need to have some relationship somewhere, within your application. So there's this property called a reference. And what that does is it just allows you to create a one-way relationship between two models. So it's highlighted here in on the screen. You'll see that there's a book model and there's an author model. And you can see that the book model has an author column that references the author model. And what you can just do is you can create an author and create a book and pass the author to the book, and SQLAlchemy knows how to save both of them and just create a link between them. And the way it does this is it creates something that we call a pointer, which is just really like a small JSON dict that stores the key space, the table name, and the key of the model that it's pointing to. And whenever you touch that model, it can actually read that property, transport it from a database, and give it to you. So you can define really simple relationships doing this. Um, I think the easiest way to look at this, to go through this is just look at some sample code. Um, so there's an author model here, as you can see. There's a book model. We create a reference that points to the author model from book, and so you create an author and you create a book, and if you read the book and you say book the author, it fetches the author transparently for you, and you can work with that. Um, so that's how that works. So every model on SQLAlchemy has a key, and that key is we call it a pointer object that looks just like this. It has a key space, it has a table, it has the name of the table, and it's got the key, like a complete key that allows you to be able to fetch that model or fetch that row later. So that's a really interesting um, piece of work. Because at some point you need to kind of like define simple relationships. We don't have many to many or any of those other things that SQL has. But if you just want to point one model to another, then you can use reference to do that. Right. So Um, so I think I mentioned that every model actually has a key. Excuse me. So you can actually use that key to delete like an instance of the model later on. So you can go back if you had like an author instance, you can pass that author to the class and say author to delete, and it deletes that. If you had a key to that author, you can pass the key to delete that. If you had just an attribute, say a column that's part of the key, if it's a primary column or the primary key, you can also pass that to delete, and that does a delete. And of course, if you have much more complex models that have multiple keys, you can pass all the keys to the delete method, and that just works. So I'm not gonna waste my time showing you guys that because I don't think we have so much time for that. But that works exactly like you'd expect. Just give me a second. Right. So now the cool thing about all of this is you can actually query. I need to move this some other place. Right. Okay, so you can actually query your database using um, a model. Every model gets this dot object property that allows you to kind of like just build a fluent query, which you can actually use to build to query Cassandra really easily. So if you had an author, you can just say author the object count and get that, and you get the count. You can just say author the objects. That's all, which gives you all the objects, and you can just iterate through them and work with that. Or you can find a specific object using where you can say author the object where you can pass a bunch of columns and of course, this is Cassandra, right? So some queries may require filtering. If you don't turn on filtering, those queries are going to fail. So you can just say add a filter call before you do the get, and that executes the query for you. If you don't want to explicitly filter every query you create, you can just use filter by instead of where, and that works just fine. Um, right. Now it begins to get really interesting. Now, people are kind of like used to using if you've used SQLAlchemy or you've used Django models, you'd know that when you're building a query, uh, you kind of like use the object to actually build a query. When use if you want to query for a book, for example, you have to say book the price less than equal to 30. You have to keep doing that over and over again. It gets very clumsy if you're building a very large query. But in SQLAlchemy, we have this thing that we call the row notation. It's like a shortcut to make your queries a lot easier to read. Uh, and it does a lot of stuff for you as you'll see down the line. So if you wanted to query for books that have a price that's below $30, for example, you want to check that the book's currency is USD, you can just use book the object to filter by, and you can use the row notation. So you can either say row price less than 30, you can just say R price less than 30, and that works. And it's just neater if you're building very large queries. But you'll see why this is very important just down the line. So we think that using this row notation is actually shorter, it's easier to read, and you don't have to repeat yourself over and over again, writing the class name before the attributes whenever you're building very large queries. Um, so, uh, so queries also work for expandos, they work for arrays, they work for sorted sets. And so, in this example here, you can see that someone creates a new expando called a book, creates a new row for that, and that's stored in a database. You can query the expander by saying book the objects that contains, and that fetches all the expanders that have values called a tale of two cities. And then if it's one, you get the first value that's returned by that query, and that just works. So you can query expandos by keys, you can query them by values, you can query sorted sets also. So it works exactly like you expect. So under the hood, an expander is actually just a table that has a map attribute, like a map column, like a column that's like the map type for Cassandra. And what Expander does is that it handles serializing into that map and out of it very easily. So that set it's an object that has a set inside of it, and a an array is an object that has a list inside of it. So you can query your expando, you can query your array, you can query your sorted set very, very easily. Um, right. So I think we should just take our time and look at this one because I think getting a feel for code helps a lot. So in this example, we create the author as usual, the book. We create put two rows in database, an author called Sam Harris, uh, and a book that's tied to him called The End of Faith. And we can actually query the database to say, oh, how many books do we have? What's the count of the books? And so on and so forth. And this is an example of building a query just using keywords. You can say author the object and pass a name to it and query and get that. So that works also. And then of course, this is an example of using the row notation. If you want to use like a full word row, you can use that. If you want to use the abbreviation R, that also works. And you see why it's actually very important uh, in a few in a few minutes. So that works exactly like you expect. Again, all this code is available online. I'm going to share the GitHub repo. You can go play with it and do that. But the code works exactly like you would expect. We're optimizing very heavily for DX. We want people who use SQLAlchemy to feel like right at home and understand what their code is doing, just at the first glance. And we kind of like want to uh, abstract away some of the rough edges around Cassandra so that entry-level people can just get going and build stuff that works exactly the way they expect. Of course, down the line, um, when your app gets large enough and you need to optimize for speed or whatever, you can actually optimize your queries, optimize your models to do what you expect. Right, so that works like you expect. Um, Transactions. Um, So CQL can actually support lightweight transactions. And the way you do that is when you create a model for the first time, you can pass in this keyword called unique. You can say unique equals true. Now, when you do that, if that if that particular model or row exists in Cassandra, that question is going to fail. If it doesn't, then it's going to kind of like happen. So you can do that by just saying account of create and pass unique equal to true. Um, of course, you can also create rows by just creating a new instance of the model directly without using the create function and then calling saying account of save unique equals to true. So that works also. So if that particular row isn't unique, then it fails, right? So under the hood, it adds an if exists to the query and to check if that key is actually unique to um, uh, to to the database. If it's not, then the creation is going to fail. Um, so that's for uniqueness. Conditional updates. Man, I really love this part of SQLAlchemy. And this is where using the arrow notation begins to really shine. So when you have a model and you kind of like want to modify attributes based on conditions, you can just create them very intuitively by saying um, by passing by passing a predicate that you build from a function called when. So, for example, in the code on the screen, we create a book model, we create an instance of it, and then we can modify it by saying book.set publisher equals to Barnes and Nobles when the existing publisher for the book is Amazon Kindle and the price is over 80 and the currency is NGN. Now, if any of these conditions actually fail, the entire update actually fails, right? So using the rule notation makes it very easy for you to just specify these conditions very easily. You can build all sorts of um, conditions and just attach it to, to the set. And what it does is that during the save, it adds this conditional extensions to the SQL query to that have to pass if the update is going to succeed. So that's conditional updates. And then of course we have conditional deletes, which says, hey, remove this column when this condition is actually passed. So in this instance here is saying remove the publisher column of this book when the publisher is Amazon Kindle. So that works exactly like you'd expect. So I think we've got some code that demonstrates that. Let's just look at that. Am I going too fast?
I think this is good. I think this is good.
Okay. Okay,
Yep, good to
cool.
go.
Right, cool, cool. So, right. Um, so, so the first example just shows enforcing uniqueness, and that works exactly like you expect. If you try to create a duplicate, that fails. Let me go back a bit in case people missed that. So here we created, oh, sorry. Sorry, I think we've gone too far ahead. Is that it? Okay. So here we create like a new row for the account. If you try to create it again, that fails. And if you read the account, you realize that the update actually failed. So that's for lightweight transaction. So notice that you're not writing any SQL. You're not doing anything special to the model. The model just works like like you actually expect. For conditional updates, here we create a book, make an instance of it, and then we'll say set updates the publisher column of this book when this condition actually works, and that does exactly like you expect it to work. The same thing for conditional deletes. You can just specify conditions to as a predicate to the object by calling set, and that works just as fine. So notice how the rule notation actually makes it very succinct and very short and very easy to read. If you had to pass the book over and over again, it could get very clumsy and very difficult to understand if your update actually gets large. So yeah, that's works like you expect. Right. Okay, so let's talk about tunable consistency. So this works just like a SQL engine in SQL engine. Um, you can just import an object called level from SQLAlchemy, and you use that object like in a context manager. And when you create any models under within that context manager, it uses that consistency level. So you can actually just vary. You can say level.all or level.1 to actually get different levels of consistency. There's also an object called linearizable that allows you to set um, um, different consistency and linearizable properties that go along with your updates. The same thing with a batch. So a batch is you just import the batch and you create a batch instance and you use it like a context manager. And what that does is all the updates that happen within the batch get grouped and gets executed as one update. In this example on the screen, we use a level.quorum which just says, you know what, use consistent level quorum to do this update. Do it in a batch, put all the accounts that we're creating into one single batch and write them all at the same time. So you can structure isolation into your code by using a batch very easily. And if you use context managers, you don't have to pass the batch down the call stack over and over and over again. You can just set it on top of the context in the context manager, and all the updates within that context uses that batch and that consistency level very, very easily. So that's one neat feature. So we have an example of this. So here we just um, you can just do all the updates in one quorum, like in a quorum, what am I saying, in a batch using a quorum consistency level, and everything that happens all together. I think at this point in the code, I actually turned on debug, so you can actually see the SQL it actually emits. So, I don't know if you can see this. Can you see it? So this what happens beneath the scenes, behind the scenes. SQLAlchemy creates the batch, and does all the updates in one batch very easily. So that's how that works. You can always turn debug on or off to see the kinds of queries that's actually emitting to your database. So that's how that works. Right, so let's talk about Accord. Um, I'm really excited about this one because I've been really waiting for it for I've been waiting for Accord for maybe a year or 2 years. And when it came out, I was very eager to just kind of like play with it and see what we could build with it. Now, with Accord, we have this object called an atom. And what we do with it is it's just like batch and level. You instantiate it, you put an instance of it, and everything that happens within that context is actually within the transaction. So in this example, what we're doing is we start the transaction by saying with atom as atom. We define some variables within the transaction. We say, oh, atom the variables. We want the first one is a variable called old, which is a query that goes to find an account that has an email address called old@samharris.org. And then you have another variable called new that tries to find an account that has an email called new@samharris.org. And then we can now begin to put conditions in transactions. You can say when when old is not known and new is known, which is a fancy way of saying if there's no account that has the new email address, then you can do an update. So Atom actually works. It works with models very easily, and under the hood, it creates Accord transactions, and it creates the conditional blocks within them very easily, and it works just like you'd expect. There's actually a lower level API that has like a builder interface that you could use to build transactions, but it gets very verbose as you use it. So this is like a nice syntactic sugary level on top of it to make it easy to use. So of course, when you define variables in an atom, you can use those variables to do comparisons. You can say find me like an object that's a book whose ID is blah. Find me a person whose ID is blah, and then we can say when the title of the book is this, and the person's age is that, and title and the price is that. Do this update. So it becomes very intuitive to kind of like build these very expressive queries within the atom, and it works exactly like you'd expect. I'm going to show you an example of this, and we'll turn on debug so we can kind of like see what it does like behind the scenes. So we create an account and a profile, and then we create instances of that, 2 rows in the database for that, and then we'll try to update that in Atom. And basically, we're saying here that if there's no account that has this email address, then updates the old email address to the new one. So this is an example of updating an email address in a user profile using Accord. Right. So you can verify that that update actually works by reading the account table again and seeing if the update actually applied. So I think we have debug turned on here, so you'll see it actually emits. Oh, sorry. Right. So it actually creates the account and actually emits the right Accord query for the transaction, and it just works. So yeah, so you can build very expressive transactions that work very well with your models. You don't really have to modify the models. You don't have to learn anything new. And it also works with references and all that stuff as you code. So there's that. I'm not sure if we have another example here. Oh, I think we do. So this is an example of using Accord with comparison operators. Now, the cool thing about this is if you try to do something that Accord doesn't support, SQLAlchemy tells you as soon as you try to run your code, right? So there's all sorts of guardrails under the hood, make sure that you are doing the right thing. So this is an example of using an object reference within an core transaction, and using different kind of comparison operators on like within a core to do an update. So we can run that, and that works. That works the way you'd actually expect. Sorry, I don't know why I was scrolling here, but okay, that's that. So it generates the core transaction the way the way you expect it to look, and it's actually pretty neat. It's actually, you know, what you'd expect to see, and that works just fine. Right. So, now that we have batches that can give us isolation across single partitions and multiple partitions, and we have a code that can give us transactions, we can finally add like a unit of work to SQLAlchemy. Now, this wasn't possible with SQL Engine and earlier ORM mappers or ODM mappers in Cassandra. But now that we have it, we can actually build a proper unit of work into SQLAlchemy. So the way we do it with the library is there's an object called a session. You create a session, you add rows to it, and you just call save. And if you modify that any object you add like to that session and you call save again, it detects those updates and it's and executes the update transparently for you. So what session does is session gives you like a unit of work boundary. So you can group all the updates for any business transaction you want to execute within your app into one unit of work. Then you can push your database like at once. It also gives you an identity map. So if you have many objects that you've put in the database and you try to read them out, you get exactly the same object. So there's this weird, very popular bug on like in Django where you create an instance of an object, or you read an instance of an object from a database in one thread or in one session or in one part of your app, and then in another instance of your app, you read the same object and then you make a modification, and what happens is if the modification from one overwrites the other, you'd have this very weird bug that's very difficult to track down. So session actually makes sure that you have the same object in use across your app. And really, the way to use session is just to proxy all of your operations through it. So you can read from a session, you can add objects to a session, and session works very well with batches. It works very well with atoms. And so what this means basically is that if you save a session within a transaction, it joins a transaction. It doesn't create a new one. If you save a session within a batch, it joins that batch. It doesn't create a new one. But if you call session that save outside a batch or a transaction, then it creates a new batch under the hood or a new transaction, and then it does the update for you. There's also something that's really cool about session. Session tries to figure out the best way to kind of like save your object. So if your object is in a single partition, what that means is if you make a change to just one row, then session actually emits an unlocked batch, which is really fast. Now, if your update is in multiple partitions, so you make the object with two different rows stored in two different nodes in Cassandra, if that update doesn't have any conditions attached to it, then what session does, the session that actually saves that update using an accord transaction, which is actually faster than using a logged batch across multiple nodes. So in terms of performance, an unlocked batch a typical unlocked batch takes about 20 milliseconds or less to execute. A logged batch can take as much as 150 milliseconds, which is like 10 times slower. And then an accord transaction takes about 30 to 50 milliseconds, which is like 2 times slower than a logged batch. So by using session, you actually get the very best performance for your code. and you don't really have to worry about whether it's an unlocked batch or whether it's a core transaction or whether it's a logged batch under the hood. Session that figures out the right way to store that stuff, and it just does the work for you. So you get a unit of work boundary, you get an identity map, and you get this optimizations under the hood that makes your code very, very performant. In this day and age where people want their APIs or their endpoints to return under 300 milliseconds or 400 milliseconds, uh, using an unlocked batch can be the difference between actually having like a really fast web app or fast API and having a really slow one. So when you use a session, it kind of like manages all of those details for you. Um, this is how that looks like in real world usage. So we're going to debug in this one because we want to see what happens under the hood, and then we quit a session, and then um, we we save that, and it just works like you'd actually expect. So once you add an object to a session, any modification you make to it is tracked, and you can query for an object through a session. You can just proxy all your operations through it to get what you um, actually expect. Um, right. So, right. So under the hood, the session can create a batch. It can create a transaction and a core transaction. It can choose to make the transaction, the updates an unlocked batch or a logged batch or an a core transaction. And it picks which to use based on by analyzing your code and the queries that you add to it to figure out if you're really in a single partition or if you're in multiple partitions. Then, of course, if you're building any web app or building an API using Cassandra, you want to be able to export your model to JSON very easily. So we've built an extension into Marshmallow. Marshmallow is probably the most popular serialization library for in Python right now. Um, and people who build like enterprise scale like apps prefer to use Marshmallow. There's a newness in Pydantic and all of that, but Marshmallow works very well across SQLAlchemy. Works very well um, with different kinds of ORMs, and we've built um, an integration between Marshmallow and CQLAlchemy. So which means that your model is basically for your model for SQLAlchemy is also your model for serialization and deserialization. So it's really intuitive. All you need to do is you can just inherit a model schema and say I want my entity to be a book, and that creates an object that you can use to serialize and deserialize your row into JSON and back. So that's basically how that works. You can do it in one line really, and and it tries to kind of like respect your properties. So, for example, you could say properties should be omitted when you define your model. Um, for example, you could have a password property or a password column in your model that never gets serialized because uh, of the integration. We know by looking at the properties to say, oh, should this be omitted or should this be included? And you can, of course, you can tweak that to get what you're looking for. So um, this there's an example here that does that. Um, so here the same author and book, and then we create instances of it, add it to a session, and this way it gets interesting. You just instantiate a schema object using model schema in a new, and then you can just use that to serialize and deserialize your model in one line, and that works just fine. So you just go schema.dump or schema.load, and you get serialization and deserialization for JSON. And it's pretty neat too, right? So it actually emits very compact JSON that you can send over the wire very, very easily, right? So that's how that works. Then, of course, we also have support for forms. So if you have a model and so you use SQLAlchemy or some kind of web app, and you want to be able to build a web form out of that, you can actually turn your model into a form by just creating a book, by creating a form, but just by inheriting from a form object, and that just works. So basically, you can turn your model and all its properties into a HTML5 form, which you can render on your in your templates. And also, when you have a form that's submitted, you can use the form object to validate that all the data that's coming from the form is actually valid and clean, and then you can turn that back into a model, which you can basically save in the database. And so we do that actually using also a very popular framework called WT Forms, which is also really good. I think it's over 10 years old. It's been used in Flask and a bunch of other web frameworks. So it just does the integration very transparently for you, so that you can take your model, you can serialize it into JSON and back. You can create a form out of your model. So you can actually print out, you can actually, what's the word now? You can turn your model into HTML5 form in your templates. And when people submit data using those forms from the web, you can use the same form object to validate that data and then turn that data into a model, which you can also save in your in Cassandra. So showing you how to use WTF forms, WT forms, and a Marshmallow is really out of scope. But people who have built web apps actually know that without these libraries, you can actually build anything modern. So we do all the integration work for you and make it very easy for you to turn your model into JSON or into a form and get data in from that and out very easily. So yeah, I think this is the end of part one. Um, I don't know how much time I've used. Is that an hour already? Unbelievable. Right, so you can actually get the code for the CQLAlchemy project on GitHub. Is live right now. You can go try it out. These slides and the samples and the videos are also here. You can go and look at that and try it out, and it works. It works just fine. The docs are still work in progress, but when docs come online sometime in a week or so, they're actually going to live here. So all of the code and the slides and samples are all here. Um, and so that's it. Thank you so much. Um, that's all I have for you today. Um, yeah. So I'm hoping that Rahul and Mariah are going to give me a
Hey,
chance to do a part
can you
two.
copy those links?
Yeah, do you want me to put the links? Put the link in the chat.
Yes, if you could drop the
Okay.
links in the chat, yeah, that way people can give you
Yeah.
some stars.
Okay.
Yeah, get some promotion
Okay.
there. Yeah, great.
Okay,
No,
I'm gonna do that. I'm gonna do that right away. But
I
yeah.
was really happy for you to give this presentation because I learned a lot about uh, Pydantic, Pythonic coding that I hadn't like really gotten into.
Yeah. Thank you.
Making sure there's no feedback. Yeah, so just great presentation on programming in general. I think this is amazing that we recorded it for posterity. Somebody's going to watch this and learn how to do the stuff. But what I'm excited about your next presentation for sure. Now, we usually
Yes.
have some time left afterwards for Q&A if anybody has any questions or open discussion. So feel free to unmute yourself and ask if you'd like. I've got a couple of
Please
questions.
do.
So
Okay.
let's say that first of all, what is stackable SH? Because that's kind of your company. So tell me a little bit more about stackable SH. How do
Right.
you
So
use this work that you're working on, obviously for something else that's important, right? Like you just don't do it out of like the goodness of your heart. You're actually using this somewhere. So like tell me how you use it for your work.
right. So it actually has it's licensed under the Apache 2.0 license, so you can actually use it for anything you want. Um, so we're using Stackable right now to we've been thinking about a good home for the project. Because we're actually like a banking startup. We're building a bank in Lagos, Nigeria. We just got our license, and we're using Cassandra as very core at the very core for like to build our core banking software. And a lot of this work is stuff that I've been doing on and off over the last decade, believe it or not. Um, and and I just didn't think it was right to put all this amazing like work, like in a bank or tied up with some license that people couldn't use. And so the intention is to create a nonprofit and uh, use an open source license that people could actually just adopt and put the code there for people to just try and use. We have a lot really planned out for this. We've got some docs coming up. We've got a lot of tutorials because this is actually like you could write 2 or 3 books out of this. And when you look at the quality of documentation that you have on SQLAlchemy and other ORMs, you would realize that you need to give people a lot of examples and a lot of content to make them comfortable, to kind of like build their stuff in this thing. And so over the next couple of months, we're going to do a lot of work around documenting this, creating examples, doing tutorials, maybe throw in 1 or 2 courses there, so people can actually just try this stuff out and use it in their own
Mhm.
projects. So it's licensed Apache 2.0, no gotchas.
Cool.
Yeah.
Very cool.
Yeah.
Yeah. I mean,
Yeah.
I have some use cases already. And
Cool.
yeah, definitely. I think I'm gonna take the Cassandra Link site and see if I can take the data and have it basically be done in CQLAlchemy, as the data layer for this knowledge base, right? And from what I
Good.
understand, technically, once the model is written in Python, it doesn't really matter what the engine is.
Yes. Yes. So the data that it emits is good old-fashioned CQL, and it's
Hmm.
portable across different environments. And
Hmm.
those properties in your models actually do validation to make sure that it's the output is the exact Cassandra type that you kind of expect. So you
Hmm.
could use SQLAlchemy to read stuff that was written in Java, for example, or you could write stuff with SQLAlchemy and have someone who's using a Java environment actually just go and consume that. No issues.
Yeah. I wonder what
Yeah.
effort it would take to try this out with CQLite. Like, what would be the integration layer? I don't know what the CQLite integration layer looks like with this, but if that's, dude, it's phenomenal. With this code and SQLite, if there's a bridge, then it just makes vibe coding like ridiculous. It makes it ridiculous
Yeah.
because like technically.
But we tend to tiptoe around Cassandra a lot in the community, and we easily forget that Cassandra is actually really powerful and really fast. Um, and people just tiptoe around it, and I think it's because uh everyone is so smart and everyone is trying to be very performant and is trying to write great code and so on and so forth. But the average engineer just wants to store stuff and query it, and when he gets traction like in his company or her company, and it needs to get faster down the line, then they can
Mhm.
optimize that. Right, right. So, but Cassandra is actually, if you run just a single instance of Cassandra, like just one instance, not in a cluster, you can very easily put 200K right into that thing per second.
Mhm. Mhm.
You could do thousands of record transactions per second on that thing. I mean, you could attempt that on Postgres, for example, right? And if you had a cluster of say 3 machines or 5 machines or seven, that just scales linearly, right? And you could do amazing stuff there. So I think we need to abuse Cassandra more, right? We need to abuse it more. We need to write code that's going to stretch it that we'll have to optimize later. And I'm hopeful that will allow a lot more people to try Cassandra out and also allow us to find very interesting ways to make the database useful for ordinary people. That's my thinking.
Yeah, No, that's cool. Definitely a lot to unpack. I think for me, I'm just really in awe of what you have here. So I'm glad you published it, as we were talking earlier. Once you publish it, it takes a lot of courage, but I'm glad you're contributing to the Cassandra community. Um, any other
Yes.
comments, questions from the group? I've got a couple more technical questions potentially. Um,
Please fire away.
Okay, so let's say I have a model and I need to make a change.
Hmm.
What changes are possible? What changes are not possible? Now, I understand that, like, technically, if I don't know Cassandra, I don't know certain things that are not possible,
Mm.
right? So, like, what do you allow the user to do and not allowed to do?
Right. So users can just modify the attributes of their objects like it's Python and just call save,
Right.
right? And
Sure.
and if yeah, and so as you get much more technical and you get to understand Cassandra more, you can and you say, oh, I want to have conditional updates, I want to have conditional deletes, oh, I want to add an index, oh, I want you can add those things progressively into your app, and it just works, right? So the goal is to make DX really, really, really great, so
Mhm.
ordinary people can just get started, right? And then as you get more and more familiar with it, you can go deeper and just optimize
Sure.
your use case. So yeah,
Yeah.
so that's the way it's designed. So
So,
it's like having a Python object or a dictionary that you can update.
yeah. But, like, do you
Yeah.
make sure, for example, it does have a primary required, or do you infer one if they don't do it? Like, how loose do you let
Right.
them be?
So
Yeah.
right. So when you inherit from model normally, um, every model has a default primary key that's a UUID. So when you
Internal.
create a new model, for example, internally, you don't need to create an ID explicitly. But if you want to change your ID type to
Hmm.
maybe a string or to an email or to a phone number or
Sure.
something,
Sure.
you could just define the ID explicitly and say you want it to be the primary key. But by default, there's an ID for every model. So that just allows you to just create your model, add some properties, and just start adding stuff to Cassandra.
Hmm.
Yeah. So by default, there's an ID, but you can change that by just creating your own ID and making it a primary key.
Hmm. Hmm.
Same primary true. Yeah, that's the way you do it.
Got it.
Of course,
Got
you
it.
can also have custom keys and all that. You can actually add as many keys as you want by just saying key true, key true, key true.
Hmm.
And SQLAlchemy is order aware, so it can
Uh-huh.
figure out what is actually a primary key and
Uh-huh.
what is a clustering key and
Yeah.
what's it's like a secondary key. You can figure all that stuff out
Hmm.
intuitively,
Hmm.
and it just works.
So, if there is a migration, what
Yes,
what happens?
yes. Cool. So there's actually a part two of this talk.
Okay,
I was
perfect.
going to plead
Perfect.
with Rahul to
Tee
give
it up
me
for next time.
to give me a chance, right? So there's so
Yeah.
much that we haven't touched. There's collections, so you can
Yeah.
actually have maps, you can have sets, you can have arrays, and SQLAlchemy knows to just save the updates that you make, right? So it
Mm.
diffs the objects to figure out, oh, this has changed, this hasn't changed, and it emits CQL that just has that update, right? And then this very nice abstraction around counters that avoids all the anti-patterns around counters, right? So you can actually have counters that you can save and update without getting into trouble. And then of
Sure.
course models look very simple at the surface, but there's
Yeah.
all sorts of bells and whistles that you could modify to do really complex and really really advanced things. So there's also a Fluent API if that's your
Mhm.
thing. There's
Mhm.
that. And I mean, there's so much that's actually here, but we can't get into it all in just one talk. So hopefully in the future we could do another talk where we talk about we do migrations, we talk about migrations and other really advanced topics. Yeah, let me see.
That's
Oh,
amazing.
okay, let me. Yeah.
That's amazing. We'll hang on for another couple minutes
Oh,
before we wrap it up. Any questions, comments? Um, let's see if there's any in the chat. Yeah, I'm blown away. This is a lot. a lot to digest. As I said, I'm going to try to not try. I will do my best to get Claude Code to do its best to use your library.
Yes. 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 Yes.
So this is
Cool.
amazing.
Cool. Cool
Thank you so
stuff.
much, Irosio, for joining us. And yeah, we'll
Thank
get
you.
you on the calendar for part 2 in a couple more iterations of PlanetCassandra. Thanks for everybody else who joined. Thanks for joining us, and your support is appreciated. Please join us next time. It'll be July 22nd. There's actually Patrick and Johnny Miller are going to be giving a presentation. So I'm just putting it out there, and I'll be on the calendar.
Can't wait.
Yeah, it'll be cool. Cool.
Right. I really hope this wasn't too fast for everyone. It's like a lot to grok in an hour. Yeah, but so I'm gonna hang around for another 20 minutes or so in case people just want to chat or ask questions or or
I can
explore live
chat with
code
you.
here. Yeah, if you
Nothing more than nothing more than what I want.
Yeah.
Most is to just talk about Cassandra like all the time, right? But yeah, I'm thinking like when I think of SQLAlchemy, it's in a lot of different systems. Technically, an existing SQLAlchemy project could be ported to Cassandra like that. Basically, also like your structures are similar enough.
So, so the basic idea is to have people reuse all the stuff they've kind of like learned from other frameworks. You want to just make it easy for people to just reuse that knowledge. Of course, you also want to improve things a bit. I mean, SQLAlchemy was built over 20 years ago. It's got crafts from old Python versions, stuff that shouldn't be there now. And it's become huge. I think it's got over 1 million lines of code right now.
Wow.
1 million lines of code. Yeah. Oh yeah. SQLAlchemy is actually that complex. So what I've done is just pick the best parts of SQLAlchemy. I've also ripped off some ideas from John for SQL Engine. That was also really cool. And just reuse these ideas to see what we could build for Python today. That will just create an easy entry point, for people who just want to try Cassandra for the first time. I think when Accord or when Cassandra 6 comes out, you're gonna have a lot of attention coming into Cassandra again from all kinds of people. All kinds of people who haven't used Cassandra before, or who tried a few years ago and couldn't find transactions, or who tried and couldn't understand how to grok writing code the Cassandra way. You're gonna have new eyeballs again. I think we need to invest more time into building tools that make it easier for people to just try things out and make it harder for people to make mistakes, right? So I think that's what this is about for me. Yeah.
Yeah, I think the code looks clean, which is what ultimately with vibe coding, whatever it's creating, you have to be able to look at it at some point. Especially
Right.
Yeah, especially if it's something important, right? You have to look at the code. You can't.
No, so this wasn't vibe coded. This is all.
No, I know it
human,
wasn't. I'm not saying that. I'm saying because no, it's clean, right? You're setting a good example, right? It's very clean. That's what I'm thinking is like ultimately Python is a really accessible language for a lot of people. Very accessible because it looks very easy to understand, although I think from the systems perspective, we have to have these libraries to work at the database level. I think that the next generation kind of programming language is really Markdown and YAML and JSON.
Hopefully not.
Well, I don't know. I think Python packs a good punch, right? Like you can pack a good punch with it. It's just
Yeah.
like by the way, I appreciate the connection to the forms engine. Because oh my God, like they have to maintain another thing now. I mean, are you serious? Like I like that. It's already kind
Yeah.
of built into it.
Yeah.
So
Yeah.
I like that a lot. So that's why I'm willing to experiment, right? I'm gonna be like, hey Claude, look at this thing. Here's a dump. Here's a JSON dump of my old workspace from this other database, and
Yeah.
it has all the
Yeah.
relationships and everything, right? Yeah. Hey, thanks for
Mm-hmm.
joining us. Yeah, appreciate it. Um, and essentially, that's where I'm like, okay, I can see this happening. I can see this thing reading my JSON structure, creating
Mm-hmm.
CQLAlchemy objects, right? Models, and
Yeah.
inferring some basic relationships
Yep.
from JSON. And if it has this forms engine, dude,
Mm-hmm.
it's already a built management system.
Yeah.
So that's my
Indeed. Indeed. Indeed.
that's my
Yeah. Yeah. I
hypothesis.
agree. I agree. I hope to maybe in a couple of months from now. There's still a bit of work around that we need to do around just making it like integrate much more seamlessly into Flask
Ah,
and Fast
yeah,
API and Django. So I mean, like you could you could use SQLAlchemy and Django today, uh, but what you want to do is that you want to make the integration a lot more seamless. You want to plug into the command line tools in those projects. You
hmm
want to make it easy to generate models and all those types of things. Um, so yeah, there's still some work that we need to do around there. And of course, the more people actually use this stuff, the more AI figures out how to make it easier for other people to use, right?
yeah,
So I think it's going to be super easy for Claude to just take some YAML or take some JSON and generate some models for you,
yeah,
and yeah, you're good to go.
yeah.
Oh, but by the way, there's actually a package. It's not published yet, but we actually have a reflection package that allows you to take SQLAlchemy and point it to a database, and it's
Nice,
going to look at the schema and generate models for you.
nice, nice, nice.
Right? So
Very
like auto mapping. Right,
nice.
yes. Yeah. So that makes it very easy for you to work with existing legacy systems. You can query them and all of that stuff. Right. So maybe another 2 days or 3 days or so, that's it's gonna go, it's gonna
hmm
go, it's gonna be published on GitHub. Yeah, so AI is good. It's really good. And I think people are going to become a lot more productive with it. But we need to lower the bar of entry. We need to lower the entry bar. So ordinary people can use Cassandra. That's what I think. We need
There
to
was
do
a
that.
there was an event I was at
Yeah.
IBM. They were showing off spec-based coding. It would have been a great event for you to be there. And nobody knew the difference basically between SQLite, right, or
Wow.
Cassandra. A lot of people were
Let's go.
non-technical,
Yeah.
right? But one guy asked,
Yeah.
why aren't we using SQLite? And the response was like, why are not we just using Cassandra? Like, what difference does it make? Right? It's easy to run, or you can just use Astra or whatever. Like, it's like, what difference does it make? And then we just moved on. We just moved on because that's where we're at now. You know what I mean? Like, that's what I'm trying to getting people to understand. It's like, dude, we're
Yeah.
at the point of, like it doesn't really matter, right?
Yeah.
Like, just use Cassandra.
Yeah.
Just say you're going to use Cassandra. Get Claude Code to start you off, and then you learn
Indeed.
along the way. Like you said, like you learn along the way, like what to do, what not to do. But I appreciate the library because it's going to make
Yep.
that generated code will be a lot more maintainable if it's easy to maintain. So
Mm-hmm.
um,
Mm-hmm.
Yep,
so
for
yeah,
sure.
Yeah.
good stuff. Really good stuff.
Cool. 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 Right. Any more questions? Is there anybody else who has questions?
I think a lot of people kind of tapered off, but there's still some people hanging out. Welcome to say hi. Enjoy the conversation. Pretty
Yeah.
low key. But yeah, let's see. People, yeah, I think people. There we go.
So, is Aaron here? Oh,
Aaron's still
he's
here?
there.
Yeah, I'm here.
Yeah, hi, Aaron. Where can I
Hi.
find more information on Astra's data API? I'd like to take a look at that.
I'm sorry, what was that?
He
Where
asked
can I
about
find
the
more
Astra Data
information
API.
on
Oh,
Astra
yeah,
data
yeah, yeah, yeah,
API?
yeah. Let me see here once.
Yeah, so definitely familiar with the
There it
Ask
is.
Data API. It definitely changed the game. Let's see. There it is.
Yeah. And
Indeed.
it has like a language selector, so we have clients for the data API for like Python, JavaScript, Java, C Sharp, and Go. But again, the idea is that we're kind of taking a more simplistic, approach. It's real syntactically similar to what you were doing there. Um, just in being able to like kind of
Very
chain
interesting.
things together, and yeah, it's pretty cool.
Awesome.
See,
Right.
now the
Cool.
tricky part
Pretty
though
cool,
is that the
actually.
data API works with AstroDB, doesn't really work with Cassandra. I mean,
Yeah.
it can, but the thing is that we don't advertise that because yeah, it's a
Yeah.
little tricky getting that data API set up to run alongside of Cassandra like that. It's not impossible, but it's just a little tricky, and we don't want to open up the can of worms of you know a lot of people trying it and having a terrible experience with it. So Astra HCD DataStax Enterprise works great.
Yeah.
Yeah.
We'll
No,
get there.
that's yeah. No, very cool. Um, yeah,
Indeed.
I would say like it'll be cool to see if we can get SQLAlchemy working with. I mean, it should work exactly the same way with the Astra CQL endpoints. So
Right,
it should
right.
work exactly the same way. Um, yeah,
Right.
Astra. Yeah, go ahead.
Yeah, so I haven't actually tested it with AstraDB or Scylla yet. Um, well, it's something that we'll take a look at down the line. For now, we just want to get this out there
Yeah.
uh, and get back to work and get back to work because this doesn't pay the bills. We want to get this out there, get back to work, and then but there's a lot planned out. We actually want to. Um, because there's still a lot of gap in documentation and like in the Cassandra community, right?
Right.
We don't really have very clear. I mean, like Patrick is doing a fantastic job with the new docs that he's building. I can't wait for that to actually come out. For it to come out. Yeah, and I'm hopeful that AI can make it very easy to write great docs.
Yeah.
Yeah, but it would be good to kind of like have um, just one place that tells you, how to get started
Yeah.
and how to build your app, shows you examples of apps that you can just clone and run, and it tells you how to make those apps really performant and how to set up backups for your cluster and all of that stuff.
Mhm.
I know that data scientists used to have a university, right? Used to
Academy.
have data.
Yeah.
Yeah,
Academy.
at Academy, right? Yeah.
Hmm.
Yeah, but was that paid? I can't remember anymore. Was
It
it
was
paid
free.
or
I
was
sent a
free?
lot of people to it to get the knowledge. Yeah. It was free. I think it was free. Yeah, that's
Wow,
true.
it
Yeah,
was.
yeah. There's
Yeah. So yes,
yeah,
so there's a lot of work to do around like just documenting this thing
yeah.
and uh, making it easy for people to kind of like find and use. And of course, your project, Cassandra Link, is also a great resource. You want to have just one place where you can see if you can find all things Cassandra. I think that's a really cool initiative. Um, um, I think I should ask Aaron since it's here. Uh, do you what are the plans for Cassandra now that DataStax is part of IBM? Uh, what do we have like any cool things that are in the pipeline that we should expect? Um, do you have
Yeah,
because I
spill the
know
beans,
that
Aaron. Spill the beans.
I don't know that there's really a whole lot, I think IBM is still trying to feel out, what it means to be a player in the Cassandra community. So, we're doing our best to kind of help that along. I
Right.
know a lot of the focus right now has been because, again, IBM's main focus is enterprises. So there's
Yeah.
been a lot of like enthusiasm around that aspect of it, which, you know, at some point will like, waterfall its way down to the open source folks. But yeah.
Right. Right.
Yeah,
Uh,
I'd like to say there's cool things coming, but might be a little big yet.
right. Well, I mean, you guys have got the resources to do really, really cool things. So you need to pull the strings to make it happen. You need to pull the strings to make it happen. Then Mariah is here also. Let me ask her, when are we going to have an entry
I will say
level
this,
chip
I
cluster?
have
When are we going to have an entry level
entry
chip
level what?
cluster on Insta cluster that you could use?
An entry level what?
Like an entry level chip
Yeah, I didn't
cluster.
catch that either.
You've got an
Oh,
Insta cluster right now, don't you?
yeah. So we do have like free trial. And I know that we were doing, so actually we were, I think this is something that might be coming down the line. I don't think I can actually say
Okay.
anything. Nothing, I don't know if anything is formalized, but this is something that comes up a lot because when we've done like meetups, people want to try it out.
Hmm.
And
Yes.
sometimes, like right now, the best thing we have, whether we're doing like a workshop or we're doing a meetup, is to send them to like a 7-day free trial, which, you know,
Mm,
you know, it's okay, but it's not really like it'd be nice for someone to be able to test out a cluster for like a month long, or just to have like something
yes.
low powered that they
Mhm.
can just kind of noodle around on. Um, but yeah, we do get that a lot. So I'm hopeful that in the future we will have something like that.
Yeah, yeah, that would be really cool because you want to have, if you have like a site that has documentation, you want to be able to run, like run your CQL and test your stuff live on the internet.
Yeah.
Just to play around and get a feel for what's possible and what's not. I think there used to be one on MongoDB.com many years ago. I'm not sure. Um, how that's going. But I mean, a lot of work has gone into, I know, for example, like in the Postgres community, they've done so much work that makes it so easy and so cheap to pack so many different Postgres projects into one tiny small database, with very little resources, so that you don't have to spin up multiple machines. You can have something very small running in memory somewhere, and people can just log into that and try it out on the website, run some queries, and kind of like just get a feel for how things work. I know that Cassandra is still a bit fat, right? But I'm hopeful that down the line, it's going to be easier for us to kind of like just pack it into something that you could just run in memory, and just try out. For example, one thing we do in-house a lot is that we find that we have to run Cassandra on RAM. So we create a RAM disk, and we run Cassandra on the RAM disk. If we didn't do that, our tests could take maybe 30 minutes or 1 hour to complete, right? So we have to create a RAM disk and then run Cassandra on that. And that just cuts down the test time to maybe 4 or 5 minutes, which is actually a big deal. So I think you guys have got the resources also to to make this happen. And now that I have your attention, I want to ask you, please pull the strings. Let's have an entry level cluster or entry level, even if it's just one instance, right? That gets reset and has like a limit on how many key spaces you can create, so people can just try stuff out. I think
Yeah,
that sounds really cool.
I agree. I will
Yeah.
I'll send that up the ladder. I actually have to jump
Yeah.
off now, but it was a pleasure to have you present. I learned so much, and I can't wait to try it because I used to use like SQLAlchemy
Hmm.
way back when, and so this is kind of cool to see it come over now for SQL. So thank you, and hope to see you for part two.
Thank you so much. Thank you. All right, Aaron. I have to jump now. I've actually got kids,
Yeah, same here.
and
Have a
they're,
good.
they're going to barge in
Yeah,
any moment from
and it's
now.
super late. Must be super late, right? What
Oh, I
time is
know.
it?
Yeah.
Yeah, it's 7:30 p.m.
Ah,
7:30 p.m.
It's not
Yeah,
terrible, but yeah.
yeah, it's not
Yeah.
terrible,
Yeah, I'll get this all edited up once Rahul gets me the Zoom movie, and then we'll get it out on
Yeah.
our YouTube channel right quick.
Cool.
So
awesome. Thanks again,
Thank you
Irosio.
so much.
Appreciate it. Have
Thank
a
hey,
you.
wonderful
nice
evening.
job, Rosio. Thanks, bud.
Take care.
Thank you. Thanks. Bye.
Bye-bye.